Exercise 6, sum number 1. Solve the differential equation d minus 1 into y is equal to e raised to 3x. Now, this differential equation, the solution will have two parts. Y is equal to the complementary function plus the particular integral. So let us first calculate the complementary function, that is CF. Now this part of the differential equation d minus 1, when you equate it to 0, it becomes the auxiliary equation. And on solving, we get d is equal to 1. So the root of this equation is 1. It's a rational and non-repeat root. So the complementary function will be c1 e raised to x. To calculate the particular integral pi. Now the given differential equation is d minus 1 into y is equal to e raised to 3x. Now comparing this with the standard form f of d into y is equal to e raised to ax, the particular integral of this differential equation is e raised to ax upon f of a, provided f of a is not equal to 0. And we can see that f of d is equal to d minus 1. Here a is equal to 3. So substituting d as 3, we get f of 3 is equal to 3 minus 1, that is equal to 2. That is f of 3 is equal to 2. That is f of 3 is not equal to 0. Therefore, the particular integral is e raised to 3x upon 2. Therefore, the complete solution will be y is equal to the complementary function plus the particular integral. That is y is equal to c1 e raised to x plus e raised to 3x upon 2. Exercise 6, sum number 9. Solve the differential equation d cube minus 4d square plus 5d minus 2 into y is equal to e raised to x. Let's call it as equation 1. Now, to find the solution of this differential equation, the solution will have two parts, the complementary function and the particular integral. So let us first find the complementary function. So consider this part d cube minus 4d square plus 5d minus 2. If you equate this part to 0, that is d cube minus 4d square plus 5d minus 2 is equal to 0, this is called as the auxiliary equation. And then find the roots of this equation. The roots of this equation are d is equal to 1, 1, 2. Now if you see, this root 1 is repeated 2 times. And the second root is 2, which is a non-repeat root. So the complementary function will be c1 plus c2x into e raised to x plus c3 into e raised to 2x. Now let us find the particular integral. Now consider this general form of differential equation f of d into y is equal to x, where x is equal to e raised to ax. That is f of d into y is equal to e raised to ax. Now our given differential equation is of this type, that is capital X is equal to e raised to ax. Therefore, its particular integral will be equal to e raised to ax upon f of a, provided f of a is not equal to 0. Now, the particular integral pi will be equal to e raised to x upon f of 1, and a here is 1. Now, we can see that f of d is equal to d cube minus 4d square plus 5d minus 2. Therefore, f of 1 will be equal to 1 cube minus 4 into 1 square plus 5 into 1 minus 2. That is f of 1 is equal to 0. However, f of 1 should not be equal to 0, but we see here we calculated that f of 1 is equal to 0. Therefore, the particular integral now will be x into e raised to x upon f prime of a. That is, we have to find the derivative of f of d. That is, f prime d is equal to 3d square minus 8d plus 5. Now let us substitute d is equal to 1 in f prime d. Therefore, f prime 1 will be equal to 3 into 1 square minus 8 into 1 plus 5, which again is equal to 0. That is, f prime 1 is equal to 0. However, we see the condition over here, f prime of a should not be equal to 0, but we are getting here f prime of 1 is equal to 0. Therefore, The particular integral will be equal to x square e raised to ax f double prime a provided f double prime a not equal to 0. That is, we'll have to calculate now the second derivative. Therefore, f double prime d is equal to 6d minus 8. And substituting d is equal to 1, we get f double prime 1 is equal to 6 into 1 minus 8, that is equal to minus 2. Now we can see here that f double prime 1 is not equal to 0. So we can use this particular formula to calculate the particular integral. That is, the particular integral is x square e raised to ax upon f double prime a. Therefore, the particular integral is x square into e raised to x upon minus 2. As we have calculated, f double prime a is equal to minus 2. That would be equal to minus x square e raised to x upon 2. Therefore, the complete solution is y is equal to the complementary function plus the particular integral. That is, y is equal to c1 plus c2x into e raised to x plus c3 into e raised to 2x minus x square e raised to x upon 2. Exercise 6, sum number 11, solve the differential equation d square minus 2d plus 1 into y is equal to e raised to x plus 1. Now, the solution to this differential equation has two parts, that is, y is equal to complementary function plus the particular integral. So let us first find the complementary function. Now here, consider this part of the differential equation d square minus 2d plus 1, and let us equate that to 0. d square minus 2d plus 1 is equal to 0, and now this is called as the auxiliary equation. On solving, we get the roots, and the roots are d is equal to 1 comma 1. That is, the roots are rational and repeated. So the complementary function will be c1 plus c2x into e raised to x. Now let us find the particular integral. Now the differential equation that is given is d square minus 2d plus 1 into y is equal to e raised to x plus 1. Now this 1 we can write it as 1 into e raised to 0x. So the particular integral will be equal to 1 upon d square minus 2d plus 1 into e raised to x plus 1 into e raised to 0x, which we can write it as pi is equal to 1 upon d square minus 2d plus 1 into e raised to x plus 1 upon d square minus 2d plus 1 into e raised to 0x. Now, since the function here is e raised to x type, we can use the formula particular integral is e raised to ax upon f of a provided f of a not equal to 0. So, this is f of d square minus 2d plus 1. Therefore, f of 1 as a is 1 here. So, f of 1 is 1 square minus 2 into 1 plus 1, that is equal to 0. So, we can see here that f of 1 is 0. So, we'll have to apply the next property pi is equal to x into e raised to ax upon f prime a, provided f prime a not equal to 0. Now for that we'll have to calculate the derivative of f of d. So f prime d is equal to 2d minus 2. Now let us substitute d as 1 to find f prime 1. So f prime 1 is 2 into 1 minus 2, which is equal to 0 again. So we can see f prime 1 is also 0 again. So we'll have to use the third property, which says that pi is equal to x square into e raised to ax upon f double prime a. So we have to find the second derivative of f of d. So f double prime d is equal to 2. Therefore, f double prime 1 will be equal to 2. And now we can see that f double prime 1 is not equal to 0. So we can use this particular property to find the particular integral of this particular part. Now consider this part 1 upon d square minus 2d plus 1 into e raised to 0x. So we'll apply this particular property. F of d is equal to d square minus 2d plus 1. So f of d is d square minus 2d plus 1. Therefore f of 0 is 0 square minus 2 into 0 plus 1. That is equal to 1. That is f of 0 is 1. And we can see that f of 0 is not equal to 0. So we can apply this particular property. So for this first part, the PI will be using this particular formula. PI will be x square into e raised to x upon 2. And for the second part, 1 upon d square minus 2d plus 1 e raised to 0x, we can use this particular property. So the PI will be 1 into e raised to 0x upon 1. So the PI is equal to x square e raised to x upon 2 plus 1. Hence the complete solution is y is equal to complementary function plus the particular integral, that is y is equal to c1 plus c2x into e raised to x plus x square e raised to x upon 2 plus 1.